Welcome to the fourth video of traversing. In this part, we are going to learn on the concept of bearing and coordinates of a traverse. Direction is one of the most important principles in traversing, as it determines the way and path of a survey line, which later on will be very useful in determining the accuracies of the survey work. There are two types of directions in traversing. First is the whole circle bearing, or simply WCB, and secondly is the direction based on north directions. To establish the direction of a line between 2 points on the ground, the bearing need to be determined based on the available reference value or the north direction. The reference value usually will be obtained through certified plan or grant of the nearest piece of previously surveyed land. From the certified plan, bearings can be obtained between 2 or 3 boundary marks whenever available. If the starting point of traverse has only 2 boundary marks, then the orientation will be corrected using sun or solar observation. And if the starting point has 3 boundary marks, then the interior angle can be checked and compared with the interior value in the certified plan. The whole circle bearing, or the WCB, of a line is measured in clockwise direction in the range of 0 degrees to 360 degrees. As you can see in the figure below, from point A to point B shows small value of bearing starting from 0 degrees, which is the north directions. The value of this bearing in the first quadrant, therefore the bearing is less than 90 degrees. It must be less than 90 degrees. Whereas the bearing from point C to point D shows an almost full clockwise rotation, where it falls on the fourth quadrant. Thus the value is more than 270 degrees. The value will lie between 270 to 360 degrees. Alright, next is the type of north directions. There are 4 types, namely as true north, magnetic north, arbitrary north, and grid north. Starting with the true north, a true north is defined as a line passing through a point on the surface of the earth, which containing the earth axis of rotations. Okay, slowly repeat, hear it again. Okay, I repeat it. Starting with the true north, okay? A true north is defined as a line passing through a point on the surface of the earth which containing earth axis of rotation, okay? This makes it a good line of reference as it remains unchanged. The line is called as geographic longitude, okay? The vertical line, if you flat out, if you see a globe, okay, model of earth, you can see the vertical line. Vertical line is called as the geographic longitude, and it converges towards each other at the poles, whether it is north poles or the south poles. Secondly is the magnetic north. The earth acts very much like a magnetic bar, which with a north magnetic pole located considerably south of the north pole, defined by the earth rotational axis. Okay, the key point here is the rotational axis, the line that punches from the top, the north, through the south pole. Okay, thus making the magnetic north lies parallel with the magnetic lines of force of the earth. This type of north direction is not suitable for engineering project because the magnetic pole is not fixed in position and the direction of the north changes as the magnetic north changes, which continuously change the value. Okay, so it is not suitable for a good line of reference. Okay, that's it. Not suitable for a good line of reference. Next is the third type, which is the grid north. Oh, simple, very simple line here. Okay, statement here, sentence, but I will explain it. The Earth has a very vast of land and very huge, which makes our point of view seeing Earth as a flat surface. Okay, my background is geomatics and GIS. No, I don't believe the Earth is a flat surface. Okay, all right, but I agree that the Earth has a very vast of land and very huge, which makes our point of view seeing Earth as a flat surface, and the horizon is also being seen as a one straight line. Okay, this is because we are seeing it in just a small distance compared to a very huge distance of Earth. Okay, in surveying, the small distance survey has its limitation in a way that it does not require to take the curvature of the Earth as its elements in calculation. Due to this small area, it is assumed to be totally flat. But to create the line of reference or the grid line, such as the whole Malaysia, or let's say the Semenanjung Malaysia from Perlis to Johor, which has the element of curvature. The element of curvature, if we take from Perlis to Johor, yes, it present. Okay, it must be included in the calculations. All right, but for a small scale survey, the curvature need to be projected to a flat surface. Okay, what does the projected to a flat surface means is actually, if you, for example, you take a ball. Okay, please do this experiment if you want to. Buy a very cheap ball, 2 ringgits from Eco Shop. I don't know whether it's open during this MCO time or not, but if you can buy one and you want to, please try to flat it out, flat the ball. You may not able to flat it without cutting it into a pattern. Okay, there are many patterns available on the internet if you want to look at. All right, so the idea is how to flatten the surface of the ball into a flat ground. All right, that is what we call as the to project into a flat surface. Okay, it's all mathematical algorithms and formula and whatnot. Imagine the longitude of the Earth. Many lines from the South Pole all the way to the North Pole. These curved lines is flattened, forming a grid straight line. Okay, I hope you understand. Okay, all the lines is converged into one single pole, let's say the North Pole. Okay, where at the equator of the Earth, these lines is largely distant from one to another, but as it moves towards the North Pole, it will be very close one to another. Imagine that these curved lines is flattened, forming a grid types of line: grid straight line. Therefore, the grid north will be all the lines on the surface pointing upwards. Okay. Lastly is the arbitrary north, or also known as assumed north. On certain types of localized surveying, it may not be necessary to establish a true magnetic or grid north directions. It's simply to have some desirable basis for establishing relative directions within the current survey. An arbitrary direction assigned to some survey line from which all other lines are referenced to. Okay. These are all the types of north directions, but usually in traverse work, the term used is not directions or north directions. The terms that usually used is actually azimuth. Okay, the correct terms. This is because the azimuth of a line on the ground is its horizontal angle measured from the north directions. Okay, it's measured from the north directions regardless the types of directions. It is measured in a clockwise direction, but what makes it differs to bearings? This is a good question. We usually use the terms bearings in our field work, right? All right. Bearing is sometimes can be related to quadrant, such as north 45 degrees west. Okay, this is a quadrant. North 45 degrees west, from top to the left. Started from the north, turn 45 degrees to the west, which means it is a 315 degrees azimuth. Okay, it's almost all the way through. So how about 45 degrees east? North 45 degrees east, it means 45 degrees in azimuth. Remember the clockwise rotation. The reading of bearing started from the north or south to the east or west. If we apply this quadrant concept, then we definitely talk about bearing. But if we talk about from 0 degrees to 360 degrees in clockwise rotation, we might talk about an azimuth. We might talk about a bearing, but it definitely we talk about an azimuth. All right, end of whole circle bearing and north directions. Now we move to coordinates. All right, the coordinate system adopted for most survey purposes is a plane or rectangular system using only two axes at right angles to one another, as in the Cartesian geometry or Cartesian plane, as you have learned in your secondary school. As mentioned earlier, the concept of Cartesian plane is a lot similar to the Greek north, where the curvature of the earth were flattened through suitable projections. The representation of the coordinates is in the form of graph, where it has two axes. The vertical axis represents the north, and the horizontal axis represents the east. Thus, if the point falls on the south part, the point will be below the horizontal axis, and if the point falls on the west part of the quadrant of the graph, the point will be on the left of the vertical axis, and the scale along both axes is always the same. For example, in the figure, point P has an easting and northing coordinates, which written as northing value first and easting value on the right hand side. But this format is not necessarily or always this way. The origin of the system will be 0 north and 0 east, and the units of measurement is in metric unit. Okay, here we use metric unit, which is in meters, always in meters. Okay, for example, if the point is located 1000 north and 1000 east, this means that it is 1000 meter to the north and 1000 meter to the east. Bearings are related to the north axis of the coordinate system. With the bearings, the information of coordinates can be transferred through the calculations of latitude and departure. For all types of survey and engineering works, the origin is taken at the extreme south and west area. Okay, the most bottom left side. This is to ensure that value will always be positive, and if at some traversing stages the surveyor realizes that the coordinates turn into a negative value, the origin should be moved such that all coordinates will be back to positive values. Okay guys, that's all for this video. If you have questions that you want to ask, please email it to me. See you on the next video. Thank you.